So we've been doing some really cool work in football heading, and we've recreated thousands of football head impacts in our lab and discovered a previously undiscovered form of energy transfer. So we know there's massive benefits to playing sport and being active. It lowers your risk of many diseases. However, unfortunately and tragically, we see a number of footballers later on in their life developing neurodegenerative diseases such as dementia, CTE.
But for many of the players who are experiencing CTE later in their life, there may not have been a history of concussion. And so that prompted us to look for different mechanisms in the brain and look less at the whole head moving around, which would be typically investigated when looking at concussions, and actually look much more locally on a shorter timescale at the pressure wave that's generated at the point of collision between the ball and the head. Our question was whether a football generates a pressure wave that might transfer into the head and into the brain, and could we measure it?
Contact between a football and a head lasts for about 10 milliseconds, but we're talking about something right at the very start, within the first 100 microseconds, where this energy is being transferred very rapidly with very high frequency and is over before the head even starts to move.
We're very fortunate in our lab that we have bespoke apparatus that allows us to specifically control the speed and location of a football collision. We're also very fortunate because we have an advanced acoustics group at Loughborough, and by partnering with them and using very specialist measurement instruments, hydrophones, that measure high frequency sound effectively, we could record a signal that hasn't been recorded before.
So this is our big football launcher, which we use to project balls into the enclosure here where we have our surrogate head and brain model. We feel the pressure in here, put the ball on the tee, and then we fire. Firing. Now within the game of football there are many factors that can affect the ball's performance or potentially its impact severity. So we've gone about testing all of those and resulted in us doing thousands and thousands of impacts in the lab.
3, 2, 1, fire.
So we've tested things like inflation pressure, the speed of the ball, whether the ball's in a wet or a dry condition, the temperature of that ball, so whether you're playing with it on a cold, frosty morning or in a warmer climate, and of course the ball type itself. And what we find consistently through all of our impacts is that the ball type itself is by far the most influential factor on this energy transfer going into the head and brain.
Within our experimental program, we were able to test balls that were representative of various eras of play over the last 100 years, from fully leather, hand-stitched footballs through to modern synthetic bonded balls.
So many people have been really interested in the differences between these balls, and it was really interesting to us as well the first time we plotted it, and to see how big those differences were. And it didn't follow that the leather balls delivered the greatest energy transfer. In fact, there was a massive spread between different balls through the history of the game.
We didn't find any specific trends that indicate that the amount of energy transfer is increasing or decreasing over time, and it's independent of which brand manufactured the ball.
Well, what was really interesting to find was between the ball that delivered the lowest energy transfer and the ball that delivered the highest energy transfer, the difference was 55 times. Firing. So what's really fascinating about this energy transfer from pressure waves is that it gets delivered right at the very start of the collision, very quickly, and is independent of the way the ball performs and feels more generally. So there's potential to engineer the ball in future to mitigate or lower the level of energy transfer delivered from every collision.
We also hope that this finding will be of interest to neuroscientists and others researching mechanisms that impact different structures within the brain, because we've got evidence of exactly the nature of the energy that is being put into the brain every time you head a football.
Further research is needed to truly understand the clinical implications of these pressure waves for footballers' brain health, but we think we've identified a really nice opportunity here to perhaps reduce the energy transfer from collisions without changing the game too much, if at all, but recognise that we'll need to work with other partners and are really excited to do that, and the wider field of researchers in this space to hopefully make a difference.